Since we have our mobility model constructed, we can then do some interesting site analysis. The first example is to visualize travel radius. We can use this router component, specify an origin point, and do the routing with all default settings. We can then dispatch the trips by time, and this is how we can visualize the travel radius from the origin point. It is currently under the pedestrian mode. If we switch the travel mode to bike, the travel radius will basically become larger. If we change the threshold again, in this case, we can observe that the travel radius is not expanding at the same speed at all directions. It is expanding slower in this direction, which indicates these two areas are not connected well for bikers. It is interesting that in example 1, we can already start to detect the mobility problems of the site using this simple kind of analysis. And now we will proceed to example 2. Street hits and amenity hits in Urbano indicates the utility of streets and amenities by pedestrians. Here we will use the ADP data and trip engine to do the simulation. We will first load a sample ADP data from this drop-down list. We can check the loaded data in this pop-out window. We will input the ADP and run the simulation. The outcome of the simulation are the trips, which we can use to do the further evaluation. Let's first do the street hits analysis using this component. Now we can see the street hits analysis visualized on the Rhino canvas. The color of red and orange indicates a higher foot traffic, while the color of blue indicates a less number of pedestrians. The number on each street segment represents its magnitude. And if we turn off the building curve, we can start to see some trends more clearly. We can also do the amenity hits analysis. It seems that there are not many amenities existing on this map, and they are pretty concentrated in a few places. If we zoom in, we can see there are several amenities overlaid on each other in one building. We can use the building hits instead, as this computes the total amenity hits in a single building. This is how we can know the expected footfall that are going to these places. Let's play with some inputs here. Some ADP sample data has this 24-hour time dimension, and this is how it looks like in the original data sets. We can specify the index to output certain column. Now I'm going to show you a series of results at different time steps. We can also see different results when we use different travel mode. We have been always using this pedestrian mode. If we change it to car, it will show the street utility by drivers, and if we switch to bike, this shows the results for bikers. So far, we have only been using the default OSM data. What if I want to analyze for some special cases or some special events? This is when the biased factor mechanism becomes useful. This example will be using biased routing factor. Assume we know that there exists a biking trail in this area like this, and we do want our analysis to take this into consideration. Then how can we tell Urbano about this information? We first bake all the street curves into Rhino, and then reselect them back into two different components. For the biking trail, we additionally embed a new metadata with the key bike routing factor and a value of 0.5. This will basically make it only be counted as half of its original length when doing the routing, which offers it a higher chance to be the shortest path when people are doing the routing for bike. Then we merge them back and construct a new Urbano model, and we do the exactly same simulation based on this model. This is the result for the street hits analysis. We can take a closer look to this bike trial. For the sake of comparison, I drag the previous results here. We can double check that they are all in the bike travel mode. However, the performance is drastically different. We can observe pretty high hits on these streets, but in the old simulation, these routes are not popular for bikers. Now let's take a look at the other kind of bias factor. Suppose you know there is a place holding a special event. You can simulate that by giving it a higher weight that makes it more attractive. Here is an example that we choose one of the amenities here and make it 10 times more attractive than the others. We assign a factor of 10 to it, while all the others with a factor of 1. To make the factors effective, we will need to choose a corresponding destination choice model, as well as the metadata keys as we assigned it. I make a small visualization of the amenity hit results. The height of the graph corresponds to the number of hits it received. We can see that this one amenity receives a lot higher number of hits than all the other amenities of the same type. Finally, I want to stress that we should be cautious about introducing biased factors. We implement this mechanism to make this framework more adaptive and flexible. However, over-tuning your model can make your analysis questionable. In the current version of Urbano, you should only use the bias factors when you have strong evidence, such as using popularity data or ratings from Google to introduce bias.